Hello everyone, today with this video I'm going to present a real-world use case to deploy a Python module with a Cloud Run job. Previously I created the same use case but with a Cloud Run service because in real-world use cases usually we use a Python module and several files to apply our logic in the code. And I wanted to do the same with a Cloud Run job instead of a service, because a Cloud Run service is limited to 1 hour to execute our logic with a serverless approach. But sometimes we need to have a job instead of a service because a service needs to be provided by a web server in the container, for example. Previously for the Cloud Run service, we used Fast API and also UVcorn to expose our Cloud Run service in the container. But sometimes we don't need to have this kind of logic and a server to expose our application. And we only need to execute a Python application with a job. And in this case, we also can have some long running jobs with Cloud Run jobs, because a Cloud Run job is up to 24 hours. And in this case, it's really interesting to have this possibility in Google Cloud to code and prepare our program directly, for example, a Python module, and deploy it in a job. And if we want to have the possibility to execute a long-running job, we can use Cloud Run job in this case. And that's why I developed a real-world use case based on a football-related use case and data. And I will present all the code pieces and execute everything in Google Cloud and show you the result in BigQuery. And firstly, some words about me. My name is Mazloum Tosoun. I am a Google developer expert in Google Cloud and also a head of data and cloud at GroupBiz. GroupBiz is a freelancer group in France, and if you have some questions about GroupBiz, feel free to ask me in LinkedIn, for example, or X. For the videos, I develop all the time the code and publish this code in my GitHub account. And you can, for example, clone the repositories and test the code in your site, for example, if needed. And also for the YouTube channel, feel free to subscribe to the channel to support our work for the Google Cloud community. And I am also active in social networks like X, Twitter, and LinkedIn. And don't hesitate to follow me if you are interested by my content. I will show the schema of the use case directly in my IntelliJ IDE because the image quality is better. In the left side, like for other videos, I have the CI/CD part of the use case used with Cloud Build. I have several Cloud Build jobs. The Cloud Build is based on the code of this use case present in the main branch of a GitHub repository. And the first Cloud Build job, we will build and publish the Docker image in artifact registry, because I explained previously Cloud Run is based on a container, and also in this case we used Docker images. And the logic, our code logic is written with a Python module, and we will copy this Python module in our Docker image and publish this image in artifact registry. That is a repo proposed in Google Cloud. For the second job, Cloud Build job, I wanted to show how to deploy the Cloud Run job and also a scheduler that will trigger the job. with gcloud command lines, because sometimes developers and cloud engineers use gcloud command lines. After, to finish with the gcloud command lines, I will show the same use case but with Terraform, because if we want to industrialize our deployment in an infrastructure in Google Cloud and want, for example, to deploy in several environments and projects, in this case, Terraform is the best tool to do that with the EIAC aspect. And in this case, that's why I wanted to show how to do the same and create the scheduler and the Cloud Run job with Terraform resources. At the right side, I have the application part with the Cloud Run job and also the Python module. I have the cron job with Cloud Scheduler. Cloud Scheduler is a serverless service, and we can easily, with command lines and Terraform, create a cron job that targets to our job, Cloud Run job. And for the use case is a football related use case in this case, and I calculate the statistic per players like for other videos. For this part, it corresponds to the Cloud Run job. We will read the ndjson file from GCS, and the Cloud Run job is written with a Python module and several files, because in real world applications we want to separate the logic in several files with separation of concern. And as I explained previously, we need to have a Docker container, and in this case a Docker image, to deploy our and execute our Cloud Run job. We will calculate some aggregation and transformation in this job and store the result in a BigQuery table. It's good for the explanation of the use case. I will firstly show the logic of with the Python module. I have this root folder called Team League, and inside a job I have all the needed logic for my current Python module and also Cloud Run job. As I explained previously, Cloud Run is based on container and in this case a Docker image, and I have all the needed files put in this folder. I could also have put the Docker file at the root of the project, but I preferred to add the Docker file inside the folder concerning the job, because I want to put all the responsibilities here in the folder. It's okay here. I have for the Python module, the entry point of my program is a main.py file and a main method traditionally. And in this case, I invoke a method, I load some environment variables, and with the cloud storage client, I load the raw file from cloud storage. I apply then some transformation. I transform my raw data to domain data in this case. And with the BigQuery Python client, I prepare the configuration and I load the result to a BigQuery table. I think it's good for the explanation of the use case. No need to go in detail in all the element and transformation, because the goal here is to show more how to structure all the elements and deploy it with Cloud Run. I have also a setup.py file. This file allows to deploy my Python module as a package. And in this case, I need to give a name and also this syntax packages and find package. And then I could also have added all the needed packages in the setup.py file, but in this example, I choose to use a requirement.txt file containing all the needed open source packages for my current module and Python program. But the two approaches are good and possible. I need to have the cloud storage Python client and also the BigQuery Python client to read and write the result to BigQuery, and some other Python packages. My Python module separate the logic in several Python files, like I explained previously, because in real world use cases, we need to separate the logic and apply the separation of concern principle, and it's good. For all the import in the code, all the elements need to be imported from the Python root folder. My root folder is started from TeamLeague, and all the import are from TeamLeague. Then I show the Docker file. For the Docker file, I copy the requirement.txt file at the root of my container and install all the needed packages. I prepare my working directory that is called app. And then I copy the setup.py file at the root of app. And at the same level at the setup.py file, I need to copy my Python module called TeamLeague at the same level of the setup.py file. We need to have this convention to be able to prepare our Python module and package. Then traditionally I use Python with the M option that indicates I will execute a Python module here in this case. And with this syntax, root folder teamleague.job.main, I can invoke the main.py file from my current root folder. I think it's good for the explanation of the code of the Cloud Run job. I jump on the CI/CD part, and firstly, we need to build and publish the Docker image in artifact registry, because Cloud Run is based on a Docker container. I target on the Docker file, and like for the previous video for the Cloud Run service, there is a gcloud build submit command lines to do the equivalent of the 3 Docker command lines, but the gcloud build submit work if the Docker file is added at the root of the project. But in my case, I added the Docker file in a subfolder, and in this case, it's not possible to do the same with a gcloud build submit command line. That's why for this example, I used traditional Docker command lines, Docker build, Docker tag, and Docker push. I can pass some environment variables to my command lines, and it's good. After this, I show how to deploy the Cloud Run job and also the scheduler with gcloud command lines. And before to show the bash script, I will execute the Cloud Build job and deploy the scheduler on the Cloud Run job to save time. I prepared some command lines in my README file, and I jump here in my shell session and execute the Cloud Build job to deploy the scheduler and the Cloud Run job. I jump again in the Cloud Build part and show the 2 bash scripts to deploy the job and then the scheduler. I have this folder script. I show how to create the scheduler, the job firstly, sorry. For the job, I have this command line, gcloud run jobs deploy. I need to pass the job name and also the path of the Docker image published previously in artifact registry. And in this case, it's good. I pass the project and the region, and I can also pass a service account to have the correct permissions to deploy the Cloud Run job in Google Cloud. I can also specify some retries in this case and pass some environment variables to my job. For the scheduler, I have this command line gcloud scheduler job create HTTP. I pass the scheduler name, the location, the scheduler cron, the schedule interval. I can pass also a description, and I need to pass in the URI the path of the Cloud Run job deployed previously, and I have this convention to target to the path of the Cloud Run job. I need to pass the name of the Cloud Run job and run at the end. I have HTTP method in this case, and I can also pass a service account for the scheduler. I think it's good. I jump on the CI/CD part here, and I finish to deploy the scheduler and the Cloud Run job. I jump on Google Cloud, I refresh my page, and my job, my scheduler was created as expected. I go to the Cloud Run page. In Cloud Run, I have a tab for services and also another tab for jobs. I can click on the created job, and for my job, I can access also to the log of my job and also to the configuration of my job. I have all the environment variables specified here and also the service account, for example. It's perfect. I will execute because for the cron, we can also execute the cron job manually with force run here. I click on force run and jump again on the page for the Cloud Run job. The job is running. I access to the detail of the job, and normally the job will load the raw file, apply the transformation, and load the result in BigQuery as expected. It will take few seconds to finish, and we will then check the result to the BigQuery, the final BigQuery table. The job is finished. We can access, for example, to the log of the Cloud Run job. For the log, I have the expected load at the end of the job. The GSS raw file was correctly loaded to the BigQuery table. It's perfect. I also have access to the configuration of my Cloud Run job and also the generated YAML file by Cloud Run, if needed. It's perfect. I go to BigQuery. I will access to my table, refresh my table, and I have my expected lines in my table, and it's good. I will empty my table with a truncate in BigQuery because I will execute the same use case, but with the jobs deployed with Terraform. I go to the Terraform part. For the Terraform part, I have this logic with the cloud build job dedicated for Terraform. I have an init, a plan, and a Terraform apply. I can pass also some environment variables to Terraform with Terraform variables. And I think it's good. To save time, I will execute the cloud build job with Terraform. I go to the Terraform part here and execute the deployment with Terraform to save time. I jump again here, and my Terraform scripts are basic in this case, and I jump on the logic of Terraform. I have a root folder for the infra part called infra and a team league Cloud Run job. This Terraform folder propose all the needed files. I have all the Terraform variables like the project ID and location and so on. I have all the elements concerning the Cloud Run job and also the element concerning the scheduler. In locals, I prepared some local variables because I want to add a suffix on my job name and my scheduler name because I want to have a different names between the element deployed with gcloud and the element deployed with Terraform. It's perfect. I have the versions.tf, and in this case I pass the Google provider, and my backend in cloud storage is cloud storage in this case. I jump on the main.tf file. I have two resources. One to create the Cloud Run job. I pass the project, the name of the job, and the location. And in the template block, I can pass all the needed elements like the max retries and also the element concerning the containers. I can pass the path on the Docker image published previously in artifact registry, and I can pass all the environment variables needed for my Cloud Run job. Then I have another Terraform resource to create the cron job and the scheduler. I pass the scheduler name and also the retry, and in the HTTP target block I need to pass the URI of the Cloud Run job, like for the gcloud command lines. I can pass the service account, and also I need to pass a dependency between the first resource for the Cloud Run job and the second resource for the scheduler, because I want to execute my resources in the correct order, and I want firstly create the job, the Cloud Run job, and then the scheduler in the correct order. I think it's good for the explanation of the Terraform part, and I jump on the cloud build. And for the cloud build and the Terraform resources, I have the expected log, because the Terraform indicates that the Cloud Run job will be created with plus, and I have the same with the cron job and the scheduler, and it's good. I jump again on Google Cloud in the page dedicated for scheduler. I refresh my page, refresh, and I have the new scheduler with Terraform. I do the same for Cloud Run. I have my job team leak job Terraform. For scheduler, we can also access to the scheduler if needed with all the parameters. Perfect. And I will execute manually the job with Terraform. I click on force run and access to the Cloud Run job. I refresh this page and access to the job that is running. We will wait few seconds to finish, but normally it will be good with Terraform, and we will then check the result to the BigQuery table. I think it takes few seconds. It will take few seconds to finish, and it will be good for us. It's okay. I can access to the log like for the previous part with gcloud command lines. It's perfect, and I access to the output BigQuery table. Click on refresh, and I have the expected results for my output BigQuery table. I think I explained all the elements in the code. It's really good. I showed how to build and publish the Docker image in artifact registry, and showed the Python module and how to deploy it in the Docker container and publish it in artifact registry. The first cloud build job to deploy the Cloud Run job and the scheduler. The same with Terraform. Everything is in the GitHub repository, and I will add in the video description the path of the GitHub repository, and feel free to clone it and test it in your side. And we executed all the elements in Google Cloud with the scheduler and the job. I think it's good. I am really happy to share my knowledge with the community. Feel free to subscribe to our YouTube channel to support our work for the Google Cloud community, and see you soon for the next videos and use cases. Bye bye.